and you know how it is being implemented. Okay, so by knowing that, it helps you to solve the problem more ways that it is being, memorizing how the algorithm looks like in the notebook. So you just have to know that, okay, for loop has this, it performs a function within this particular jurisdiction. I mean, that is how it goes about, it works. This is how the if statement also works. And this is how it is able to make decisions. So once you know them and you have a problem that you would like to solve using programming language, you just apply them and then you'll be good to go. All right, so we talked about the enumerate and then also the zip where we put multiple lists together and we try to iterate through them at the same time, performing operations on each of them. All right. Okay, so I think we got to looping over dictionaries. Okay. All right, so we're moving to nested loop. So last time we ended at this place, whereby we perform such a bit technical and um, um, technical programming. All right, so I would like to start from the code right below it before we move to the nested loops. Okay. All right, so let's consider this code. All right, so you see that building summary statistics from a list of dictionaries. Okay, task compute the average score and identify the top performer. All right, so the average score has to do with the mean, and also we want to identify the top performer from the list, from each of the dictionaries. So here we can see that we have a list of dictionaries because each of these is a dictionary. Okay, so we have 5 dictionaries within a list. All right, and our goal is to compute the average score, okay, and also identify the top performer. So the average score of all the people or the participants or the students, we want to calculate their average score, and then they identify the top performer. So over here, we can manually do that. So to calculate for the average score, we need to add all these numbers and divide it by the total number of students that we have here, which is 5. All right, and then to find the top performer too, we would like to go through and be like, it is 91. Okay, so that's a manual input. But to use a code, this is how we do. So we use the accumulator that we learned earlier. So in this case, we set the accumulator variable to 0, which is the total, and then the top score, we set it to 0, and then the top student, we set it to an empty string. So we have this, which is an empty string. All right, so this is our for loop statement. We say that for row in dataset, and we know that the row represents each of the dictionaries within the dataset. So for row in dataset, total equals to total plus row score. All right, so this total here, we are updating it with the row score. So,
Network
so
not
Gloria,
to
please,
cool, my book.
can you mute yourself? Okay, good. All right. So here, each of the row over here represents the dictionaries here. Okay. And then we say that for total, the total over here, we are updating it with the score because we know that if the row is a dictionary here, then row score will return the value score for each of the rows within the list. So here we are returning. So your total will be updated with the score. So when we pick the first row, the total will be updated with the first score, which will be 82. And then the condition here is that if the score is greater than the top score, so initially the top score is 0. So if it is greater than the top score equals to row score. So if the score over here is bigger than your top score over here, then the top score will now be equal to that row score, which is bigger than the top score. Okay. All right. Then we are going to say that the top student, okay, will be equals to row name. So the name of that particular student who have that top score. So Python is going to iterate through these things one after the other. So first you take the 82. So for row 1, which is this row. So the total will be equals to total plus row score, which is this total plus the row score. So the score of this particular row is 82. So it's going to be 0 plus 82. So that's going to give you 82. And then if 82, which is this, the row score, is greater than the top score, which is 0, then the top score equals to row score. So it means that now the top score will be equals to 82 because the row score over here, which is the 82, is greater than the top score, which is 0. Okay, so once you are done, then you see that the top student equals to row name. So the top student will be equals to the name of the person whose score is greater than the top score, which is an AMA. So that will be for the first loop. Then Python will pick the second one, the second row. What is the score? The score is 65. So if the score is 65, then the total, which is already 82, will be equals to the 82 plus 65. And then the question is, if row score, so now it is not the total, but the row score, if this 65 is greater than the top score, which is now 82, then the top score equals row score, which is the 65. But in this case, the first condition is false. So it means that this block of code will not be run. That is to say that because 82 is greater than the 65, then Python will move to the next row, which is this dictionary. Then need to move to the next row, which is this dictionary. Then need to move to the next row, which is this dictionary. So by comparing the ones which have the score greater than the previous one, or as it compares, will be the top score. Okay, and once you are done, the total will be the summation of all the scores. And so to calculate for the mean, we say that average equals to total over the length of the data set. And we know that the length of the data set will give you the length of the number of dictionaries within, which is 5. So the length will give you 5, and then the total, which is the scores over here, and that will give you the average. Okay, so here we are printing the average score, and then we are rounding it to one decimal place, and the top performer, we are printing the top student, which is this one, which will be updated based on which students have the biggest mark, and then the top score. So let's run this code and see what it will do. All right, so now we see that the average score for all the students is 76.2, and Yao is the top performer with 91, with a score of 91. And let's see. So we can see that over here, Yao is the top scorer. So imagine we add Yao menu, the code will be updated likewise when we run it. So Yao menu, top performer is Yao menu with 91. Okay. All right, so that's about the for loop. Okay. All right, so we are moving on to nested loops. Okay, so the nested loops has to do with we are having a loop, let's say a for loop in a for loop. Okay, so we have two for loops under for loops. If you remember quite clearly, when we were doing the conditional statement, you will realize that sometimes we can have an if statement, and within that if statement, we have another if statement. So that's why we call it nested conditional statement. Likewise, when it comes to looping, you can have a loop within a loop. So that gives you the term nested loop. Okay. All right. So I think this one is important to know. So a nested loop is a loop inside another loop. The outer loop runs once per item in its collection. For each of those iterations, the inner loop runs completely through its own collection. Okay, for each of those iterations, the inner loop runs completely through its own collection. Okay, so we will see that one. So in data analysis, nested loops are used to process a table row by row and column by column, compare items across two data sets, or generate all combinations of variables. I think this one will be more meaningful when we start working on data. But this is how it works. So here we have students, okay, a list of students, a list of subjects, and these are the scores. So here we have what we call a list of lists, because within your list, we have three lists. So we call it list of lists. Okay. All right. So it's kind of more of like an advanced list. Okay. So now let's look at our for loop. So we have a for loop here and another for loop within the first for loop. So the first for loop says that for I, comma, student in enumerate student. So I would like to know what will this code do? This particular line that I have highlighted. What do you think will it will do? Is there anyone to help me out? When you say for I, comma, student in enumerate student, what would the code do? What are we trying to say? So please, what would the code do when we say for I, comma, student in enumerate student? What would the code do? Okay, so let me stick through. So we know that the enumerate, when you enumerate a list, it returns the index and then the value of the list. So for I and student, meaning that this I represent the index and this student represent the value. So in this case, we are talking about the index 0, 1, 2, and the values Ama, Kofi, Yao. So we are saying that for I, so for the index 0, 1, 2, and then for the values Ama, Kofi, Yao, in this student, what are you supposed to do? You print the student. So it's going to print the student. And then you say that for J, comma, subject in enumerate subject. So it's the same thing that we are repeating here. So you are going, the J will be the index, and then the subject will be the value, which is the subject within the subject list. Okay, what are you supposed to do? Print. So just an empty space, and then you say that subject, comma, which will be this subject over here, which will be one of these. Okay, every one of these. Then you bring your colon. Then you say that scores index I, index J. So what happens is that when you pick I, okay, so for I, comma, student in enumerate, so Python is going to pick the first I, who is Ama, okay? So here will be Ama. What is the value? Sorry, the index of Ama is 0. And what is its value? Ama in the student, print student. So the first output will be Ama, okay? Then you say that add just this colon, okay? Because it's a string, so add it. And then you see that for J, comma, subject in enumerate. So for J, so the first index will be math when it comes to the subject. So it will be 0. And then the subject is math. In enumerate subject, print subject. So here, the first subject that will be printed will be math. Okay. Then you bring this. And then you see that the scores I, J, so 0, 0, because here we are taking index 0 and here too we are taking index 0. So it's more of like saying that here we have scores 0 and then 0. Okay, so this list over here, scores 0, 0, what does it mean? So we know that for when you have a list, this first item will be in the index position 0. This will be in the index position 1. This will be in the index position 2. So you are indexing the first position. So you are going to pick this particular one. And within this list, what is the value at index position 0? It is the 82. So it means that the score of the math for this particular first person, who is Ama, will be what? 82. But you see that this for loop is not ended, so we cannot move to Kofi. So it will just the index over here will move from 0 to 2. So when it, sorry, from 0 to 1. So when you move from 0 to 1, you come to English. So here the next code within this same for loop will be English. So the second subject will be English, and then the scores will be 0 and then 1. Okay, so here you come. This is at index 0, and within this list, what's the value at position 1? At index 1, which is 75. So the English will be 75, and it repeat the same thing for the science. When it's done and the list is being exhausted, then we'll come back to this for loop again, because it has not looped through all the subjects and all the students. So it will come and pick Kofi, and it will perform the same iteration. So let's see that one in action. Okay. So this one, when you run it, you can see that you have first the AMA, and then the second loop, or the second loop will run. So it will run through all the subjects and return the scores over here. Once it's done, it will come to Kofi. Then it will loop through all the subjects and the scores for Kofi. Then it will come to Yao. Okay. All right. So this is just an example that I was showing to depict to you how the indexing work. So normally, originally, when you have a list, let's say scores, and it goes to a list, let's say 1, 2, 3. Okay, so actually this first item is at index position 0. The second item is at index position 1, and then this is 2. But in this case, instead of having single values, we have list there. Okay, so at index position 1, we don't have a value, we have a list. Okay. Okay, good. So that is exactly what is here, which is what we found over here. All right, so once you have a list of lists, it means that the value at index position 0 of this particular score will be the first list, position 1 will be the second list, position 2 will be the third list. However, this list, actually the value at index position 0 is actually a list. So for if it is a list, you can still perform an index on it. Okay, so that is why we implemented this particular notation. So first, this first code that I've highlighted will give you a list, which is this. Okay, if this is a list, then I can still index it because it is a list. And so if it is, once it is a list, I can perform all the methods that we perform on list on it. So I try to index it again. And by indexing, I want to get the value at position 2. So for this list, what's the value at position 2? So 0, 1, 2, which would be the 90. So possibly, if I'm to run this particular code, what I'm going to have will be, 72. And the reason why it's 72 is because this one is at index position 1 instead of 0. But provided it's 0, I'm going to get the 90. Okay. All right, so that is how it is. So it's just like a list of lists, just as we were doing a list of dictionaries, that each of the items over here, which is dictionary, we can perform dictionary operations on it. All right, so this reminds me of what I've been saying previously, that when it comes to the data structures, understanding them is important, because one or the other, Python will output either a data structure or a data type for you. And if you know the data structure, if you know your data structures and your data types very well, there is nothing that you can do. Okay, because here, when we index, the output is a list. If it is a list, I can perform everything, all the tasks that I can perform on a list on this particular index value. Okay, so that's the beauty of programming and kind of how complex it can be. Though if you understand your data structures and you know that this is this, this is that, you will not be shocked, because you know that it is possible to index a list. So if I've indexed a list and I'm having a list now, then I can still index that new list or that new output that I have. Okay. All right, so we have another question over here. Another example. So they're comparing two lists against each other, a lookup operation, checking which new customers are already in the existing database. So this can be like a program that you run for a particular, database, provided you let's say someone who works for a sales shop, you can just write this program, and you, instead of using a list, you just use table columns, and it can check whether a customer is a new customer or the person is already existing in your database. Now, how does it work? So here we have two lists over here. Existing customers have their list, and the new signups have their list. Okay, with the names. Okay, all right. So we are just printing a text that duplicate check. And now we are going to run a for loop, but here it's a nested for loop. So I'm going to take you through it one after the other. I would like you to pay attention as we go through. Now, what does this loop say? The first loop, this one, is it that for sign up in new signups? So it means that we are talking about this. So for each of the names or the items within this new signups, then we set a variable found equals to false. And what it means is that for each of the items, let us assign whether the name has been found to false, because we don't know. We haven't found any name yet. So we say that if it's a name found, so that is what this code is trying to say. It's a name found, no. So let's say that the found a name is equals to false. So that's how come we have assigned this found to false. And we know that this false is a Boolean. It means that it is not true. We haven't found anything. Okay, so for sign up in new signups, found equals to false. Then we come to our second loop. It says that for existing in existing customers, so meaning the existing over here represent each of the items within your list over here. Now we are going to check for a condition. If sign up, okay, which is this sign up, which is the individual items, the names over here, is equal to, now if you remember in Boolean, we said that the equal to is used to check whether two conditions are equal or they are the same. So if sign up is equal to existing, so the existing over here, which represents the names in this place. So what we are trying to say is that if this name or if the items or the names over here appears in this place, then what do? Found equals to true. So now we are changing the value of the found. It means that we found someone who is a new signer, but is also in the existing customers. And then if found, that means that if true, because we know that the if takes only true statement, print. So we just leave an empty space, sign up, which will be the sign up, the name, okay? Then you say already registered. Else print, sign up, comma, new customer. Very simple. Please, do you understand the flow? Do we understand it?
Please go over it again.
All right. So what I'm saying here is that we have two lists. Our goal is to check whether a new customer is already in the existing database, and the existing database is this one, existing customers. So once you find out whether this person who has signed up as a new customer, yes. Please, can I help you by hitting me? Okay. All right. So this, we want to find out whether someone who is saying that he is a new customer, okay, is already an old customer. So it can be like Google accounts, okay. So maybe you want to create a new Google account. Google has a database of all the accounts that has been created, but you want to sign up. So Google wants to check whether you are already you've already signed up, or you already have an account with them. Okay, so this is actually the code that Google will use to figure out. So that is the code that we are trying to implement here using a nested for loop. And so this is how the code runs. This is just to print, duplicate check. So it's not part of the code. Okay, the technical things I want to show. So what we are saying is that for sign up in new signups, and we know that for loop for each item, okay, over here in the new signups, let's assign found to false because we haven't found any name yet. We haven't found any name yet in the existing database. So let's first say that the found is false. Okay, so found, which is a variable, we've assigned it to false, meaning that we haven't found anything. For the names over here, we haven't found anything. Then we run another for loop, and then we say that for existing customers, that is for each of the names in the existing customers over here, that we are going to check for conditioning to see whether the new sign up is already here. If the new sign up, which is this, the sign up, the first loop, which is the names over here. So if the names over here, that is what this condition is saying. If the names over here, name one after the other and comparing. So if there is a name here and there is a name here, then you change the found value to what? To true, meaning that you found someone. And then once you are done, you are running an if statement, say if found. And we know that the if takes only true statement. So here, all that we are saying that if true, print sign up, comma, already registered. So it will print the name over here, then it is say already registered. Else print sign up, new customer. So let's see. So let's go through. So you can see that Edward is not here, but Bob is here. Is here and Bob is also here. So in this case, the found will be true because there is a sign up over here which is equal to the existing. So found will be true. So it means that here this particular block will be printed. So you're going to get the name, which is the Bob already registered. But when you take Edward, Edward is not there. So you're going to see Edward, a new customer. So I hope I've been able to explain it and you now understand.
Yes.
Okay, good. So let's run it and let's see the results for ourselves. Okay, so duplicate check. So Edward, new customer. Bob already registered. Fiona, new customer. Alice already registered. George, new customer. Okay, so you see what it is doing. That is if the sign up, that is if the names over here, they are also found here, then already registered. If not, so you can see that Edward, new customer. And when you compare, it's true. Edward is a new customer and Fiona too is a new customer because Fiona's name is not here. And then George too is a new customer because his name is not here. But when you take Bob and then Alice, they are already part. Okay, so that is how sometimes when you are trying to log in with when you go to sign up and you try to type your Gmail, everything, Google can tell you that this particular account is registered. Okay, so kind of double checking. All right. So that is how, yes, yes, I can hear you. And please come again because, hello. Okay. Is it this line? Yeah, hello. Yes, I can hear you now. Yes, I can hear you. Yeah, so please come again with your this. Sorry, sorry. Okay, sorry. Uh-huh. So I think okay. 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 Okay, this one. Okay. I mean, you said you don't understand. Mhm. Okay. Oh, no, no, no. No. So it could be numbers, okay? But the force over here is actually a data type. I hope you remember that. Okay, because it's a data type, all that we are trying to say is that if found equals to 0, then it means that we have to increment something. So the previous ones, the previous code, you realize that if we want to increment, add some values, or maybe count the number of times that we are performing the loop, then we can set it to 0 so that we can add it up. But here we are looking for a condition. And the condition is that is a member are those who are the new signups already existing customers. So it's a condition, isn't it? So because it's a condition, that's why we are assign the initial value to false, which means that it is not true. So we don't have a true statement. So this means that we haven't found anything. Okay, so that is the initial value. Then let us now begin to check. So now we begin to check. If we check and we find, then we will change this found value to true. Something has been found. Do you get it? Do you get it now? So it's kind of the question that you're asking is a conditional statement. So you cannot use 0 or any other numeric data type. However, because it's a conditional statement, we are trying to use a boolean for that particular task, because booleans are meant for conditional statement. If you recall, um, when we were learning boolean, so that's the reason why we set it to that. Okay. However, if it is an incremental, we want to add up. That one you can't use a boolean because boolean is not meant to perform arithmetic operations. Did you get it? Okay, that's that. All right, so we are done with the for loop, and maybe you have some question. There is some clarity that something that I didn't get it so well. So you would like me to clarify on that? I think I can do that before we move on to the while loop for the for loop. Though there are a lot of technicalities, but I think once you take the notebook and you go through, you realize that they are very simple, and you can even generate ideas to write your own personal programs. Yeah. Any question? Okay. All right. So I think silence means we are all good to go. So I'm going to zoom into um, the while loop. Okay. All right. So the for loop, when we were doing it, you see that it has a threshold. Okay. We are starting from some point to some point. When we're using the range, you see that we start from one to somewhere, or this value to that value. So it's kind of bound. Okay. The iterative process has an end. But that is not true for the that is for the for loop, but for the while loop, that is not true. Okay, it repeats a condition as long as it is true. So whilst that condition that you've given to the while loop is true, the loop will continue until that condition becomes false. Okay, so I think there are some programs that you can run and then it will not end. It will not end. Okay, okay. I would like to demonstrate that, but I think unless I create a new notebook. Okay, so let me see and demonstrate that. Okay, I think I need a new notebook. Oh wow, that's that's not too good. While true, okay. So while the condition is true, whether one is greater than that, or so while true, okay, print. This is a while loop and loops until the condition becomes false. All right, so for this particular code, if I'm to run it right now, you see that there will be an endless loop. Let's see it's in roll action. Okay, see, it does not end though. So you see that it will print till thy kingdom come. Okay, okay, so you can see that from the scroll hole over here. Okay, okay, the page scroll. So you can see that it's just increasing, and then once you go down, it's it's just adding up. Okay, so if this code is not terminated, it will run till that kingdom come. So I have to terminate it here. Okay. All right, so that is what the while loop does. So as long as a condition is true, it will run forever. Okay. All right. Oh, wait. So, okay, let me just open this. Please, I'm coming. Okay, I think because I changed this one, that's why. That's why I'm not working. Oh no, no. It's working. The network is working. Okay. So please, me, I'm using Jupyter Lab, so that's why I'm not using the notebook again. So I'm using the lab. I like the interface. That's why. So please be patient with me. I think it's loading and it will come not too long. All right. So if you want to also access the Jupyter Lab, when you open your Jupyter notebook, you'll find the Jupyter Lab here. So when you click on it, the Jupyter Lab will be open instead of the Jupyter notebook. Okay, and I think it has some additional functions, so maybe you can explore it yourself. All right, so okay, so that's the for loop. Okay, so this is the syntax while condition, while which is the while keyword, then the condition, which is your condition, actually a boolean condition. It involves some booleans. Okay, do something. Okay, update something that will eventually make the condition false. So here you see that they added something. So you have to update something in order that the condition over here will be false, or else you will be trapped in an endless loop as we saw in the demonstration. Okay. All right. So let's take an example, for instance. So here, processing patients from a queue until the queue is empty. So maybe you're writing a program and say that, okay, the first person, next person, third, until none of the persons is left. Okay, so what you're going to do is that we have the people who are waiting in the queue. So we have Ama, Kofi, Yao, Ifwa, and then Kwesi. These are the people waiting in the queue. Okay, and then the condition is while len waiting greater than 0. Please, I want someone to explain this code for me. Okay, I mean the while, we know the while, but this one, what does this code do? What does it do? What condition is it trying to check it out? So okay, and please help me. You want me to mention names? Maybe I can also try that since I haven't tried it before. I can also call you to help me do that. Okay, all right. So, but please try and then help me answer it. What does this code do? This particular code, what do you think is doing? The one that I have highlighted, the len waiting queue greater than 0. What is it? What is it saying? What does it mean? Oh yes, yes, that's very good. And the square bracket is called what? You have to know. It's what? Any item in square bracket is called. Okay. Mhm. Really? Okay. By the way, it's a try, so and that's very great. That's great. Please, who else will also help us? That's what he said. And do any of us also have some different understanding of this particular code? What does it mean? Okay. All right. So, uh, okay, then come again. Mhm. Okay. Okay, so add a while to return. Let's see the statement that you are trying to tell Python. Mhm. The while len waiting queue greater than 0. Okay. So, okay, James, so you are coming. Okay, give it a try. Give it a try. Okay. Oh, but our ladies, please kindly help us. Okay. We need your support. Okay. So, okay, let's see this. So, what we are trying to say is that while the length of the waiting, which represents 5, because there are 5 items, so while 5 is greater than 0, that is the condition, boss. So while the length, so while 5 is greater than 0, okay, but we are just using the length to return the number of items. Okay, so while this condition is true, and we see that 5 is also greater than 0, what are you supposed to do? Current patient equals to waiting queue dot pop 0. Okay, I think we have an apple. I would have asked you what would the pop do. So you remember that when we were dealing with the list, we came across pop, and we said that pop, when you do not provide any parameter here, it removes the last item. But here we are providing a parameter here, so remove the first item, okay, which is the at index 0, so it will be AMA. So first current item equals to waiting queue, which is this list, dot pop 0, so you're removing this. Print now attending, comma, current patient, so the name of that current patient will come, because the pop will also retain the name. Okay. All right. Then print remaining in queue, comma, len waiting. So when you remove this one from the list, now the length will become what? 4. So now the len waiting here will be 4. Okay. So that is the first loop. Then it goes through the loop again, because the condition is still true. So it will come and start from here again. So current patient equals to waiting queue dot pop. Now the waiting queue AMA is off, so now you have 4. Okay, the patient now attending, comma, so that will be Kofi. Then once you've removed Kofi from there, you are going to print the list. I mean the number of people left in the list. So that's going to give you 3. Then it will come to Yao. It will reduce to 2. If Y, it reduce to 1 until this condition becomes false. Then the loop will stop. So once the loop stops, because the condition is false, then it will print this one. So until this condition here is false, this code cannot be printed. So you realize that when you run the code, this code will be printed after all this condition. I mean, after the condition has become false by the updating of the length of the list based on the number of people there. So let me run it, and then let's see it in real action. Okay, so now you see that first we have the now attending AMA remaining in queue 4, now attending Kofi remaining in queue 3, now attending Yao remaining in queue, now attending Ifwa remaining in queue 1, now attending Kwesi remaining in queue 0. So because 0 is not greater than 0, the condition becomes false. Then you print this, all patients have been attended to. Please, do we understand? So a bit scenario, I mean, this is more of like a software, like something. So more scenario, like when you go to the bank in halls, kind of see index number 0. So provided we have a fixed number of people that we are supposed to sell, okay, so the machine will be looping through the number of people over there. So now attending Amma. So maybe the machine will mention the name Amma. Then it calculates. It's remove Amma from the list because Amma has been attended to. Then once the person say that we are done, then Kofi will come. Then once the person clicks, then the next person until all the people I mean registered or that have I mean, for some banks, when you go, you have to kind of type some code and other things until all the people who have registered are exhausted. So here we can append the list and maybe add James to it and then add Grace to it and then, okay, and then add Teresa to it. Okay. All right, so let's see it in action, how it's going to work. So it does the same until the last person, okay? All right, so that is how the while looping works. And it's always run the loop under it until the condition is false, okay? And that's more of like kind of an updating something. All right. So let me take any question, if you have any question, because this is our first example under the loop. So if you have any question, you can let me know so that I'll. Is there any question or we understand it? And even an emoji will be fine to let me know whether you are good or you're not. Okay, good. All right, so let's make progress. All right, so the next one is our task is to simulate investment growth until a target is reached. Okay, so maybe a company wants to simulate its growth until a target. So the target is 20,000 and the current capital of the company is 1,000 and the annual rate, okay, is 0.12. So we want to simulate the investment growth, I mean the investment of the company or the investment of an individual in a particular venture, okay, until this target is reached. So how are we doing that? So first, we are using the same while loop. So the while loop has some characteristics that is more like that of the for loop, just that for it, when the condition is through, it will run endlessly until the condition becomes false. Okay. All right. So let's see. So we say that while current value, which is this current value, is less than the target value, because our goal is to simulate investment growth until the target is reached. So while this one is less than this, so what are you supposed to do? Then the current value equals to current value times 1 plus the annual rate. I mean, this is just some formula. So we are updating, while this condition is true, let us update the current value. How are we updating it? We are multiplying the current value by 1 plus the annual rate. So kind of current value times 1.01, sorry, 1.12. Okay, then the years equals to years plus 1. So we have the initial year to be 0. So years equals to years plus 1 will be 0 plus 1. And then print years. So that will be 1. Then comma, this is just a formatting, Ghana city. So, and you say that run current value to 2 decimal places. And then you print the current value, which is this. I hope you are getting it. Okay, so what will happen is that as you multiply this current value by this, the first one it will be 10,000 by this particular factor. So now the current value will be the new value after multiplying the 10,000 by the new factor, by this factor. Then it will go through it again and compare. Is this new value that after multiplying the 10,000 by the factor, is that new value less than your target? If the condition is true, it will run the code again. by updating your current value. So the new value that you get after multiplying the 10,000 by the factor will be multiplied by the same factor again. And then the loop will go, and then it will check again. Is it less than this? So it will run until your new value, which is your current value over here, will be greater than the target value. So be greater than the target value, which makes this condition false. And then you will get this particular output. So let's see that one in action. So you see that we have the year one. That is when we multiply this factor by the 10,000. We are going to get 11,200. Because this does not satisfy the condition, we will multiply. So we multiplied until the condition. So you can see that the 22,106 is greater than the 20,000. Okay. So what it means is that the condition becomes false. Then you print investment doubled after 7 years. Okay, so once you have this investment and you want to calculate the number of years that your investment will meet a particular target, you can just use this for loop code to run the number of years that it will require for your investment to double. Okay. All right. So maybe you invest in a particular venture, and maybe let's say for yours you were very fortunate, and then the annual rate is kind of, let's say, 20%. Okay. And then maybe your target is 200,000. Okay, so you want to figure out how many years will it take me to reach this 200,000. Very simple. When you run it, it's going to give you, so it will take 17 years for your initial investment of 10,000 Ghana cedis with an annual rate of 0.2 to reach 200,000 Ghana cedis. In 17 years. It looks like a long years, but however, if you don't invest, it will come to pass anyway. And you will lose that to 200,000. Okay, so I mean, that is one of the beautiful things about programming. Okay, though it's kind of financial related, but you can use it to do anything. All that you need to do is to have a problem and ask yourself, how am I going to solve it? Just as we use the computational thinking. Okay, you have a problem, you try to apply the 4 pillars of computational thinking. And then once you are done, you draw a flowchart for it or a pseudocode. Then you begin to use the Python syntax to write the code to achieve your particular purpose. So maybe you cannot just apply it to data science. I mean, now you have a skill to even develop a model, an investment kind of predictor. Okay, so if someone invests something, and then yeah, you can. It's very beautiful, and you can even make it like a calculator by just using the the input. Okay, so you remember the inputs. So now you can say that input current value. So current value, current underscore value will be equals to. So we are using the integer in the input so that whatever thing that will be typed will be converted into an integer. So type your investment here. Hey, sorry, your current investment value here. Okay, so this is just a simple investment growth calculator. Okay, so then we take another one, annual underscore rate equals to, so that one too we say a float, okay, because we are using a decimal. So input, okay, then we say type your annual rate here. Okay, all right, and then because we need 3 variables, right? And then the target, okay, type, target will be equals to, that one is also an integer, so an integer input, so that everything that you type will be converted to an integer, type your target value here. Okay. All right. So the rest of the code, I'm just going to copy it and paste because it's going to perform the same task. Just that in this case, we are just making it manual. Okay. All right. So we are done. So we've written a program that calculates the number of years that it will take for you to reach your target and that particular target value that you get. Okay. So I think let's run it and please, I need a volunteer. Someone should tell me about his or her investment. It can be anything. It shouldn't be the actual investment that you are doing. And please give me a moment. Hey, sorry. So, please, someone should volunteer and then give us some values. Any value, maybe you have invested into some, maybe Nvidia or maybe Meta or Google. You are buying stocks and your investment. So, what's your current value? Please, anyone, just give us something to try. Our um, our software. Okay. So, what's your initial 1,000 Ghana? Okay. What's your annual rate? Mhm. Oh yeah. It doesn't matter. Just anything. So what percentage would they add to your money? What do they add to your initial investment every year? 5%. That's going to 0.05. Okay. Next. And what is your target value? So what amount of money are you expecting from your investment? That we calculate 1,000. Okay. 10,000. All right. So with your initial investment of 1,000 and annual rate of 0.05, if you want to have a 10,000 Ghana cedis on your initial investment, we are going to calculate the years. All right. See. So it's going to take you 48 years to get the 10,000. Okay. So 48 good years. All right. So, I mean, it just calculates that and it's very beautiful. However, we can just even make the code shorter. Okay. Because printing, the, all these things are not necessary though. But maybe sometimes you would like to know how much you're going to get each year. But let's say when you run the same thing, so you have 1,000 and then you have 0.05 and then you want 10,000. Okay. So this is going to give you 48 years. So your investment. Okay. So let me say your investment will be. Okay. Something. Let me just add something here in order to modify the, the formatting. Will be. Okay. Current value. Okay. After this, yes. Perhaps you forgot a comma. Okay, current value. Investment will be current underscore value. Okay. How it's supposed to work. So let's see your 1,000, 0.05. And then you have 10,000, 1, 2, 3. Round it to two decimal places. So 1,000, 0.05. And then 10,000. So once you do, you see that your investment will be 10,401.27 Ghana cedis after 48 years. Okay. So if you invest with an initial 1,000 Ghana cedis and you want 10,000, though because the 10,000 is not exact, that's why it is giving you the immediate that makes this particular condition false, and the immediate value is a 10,401. So you will get 10,401 Ghana cedis after 48 years. So if you are making an investment and you say that's why you will not do, however, the 48 years will come anyway. All right. So maybe if you have an investment with a very high annual rate, let's say they will give you like 70%. So that one, when you invest 1,000 cedis with 70%, 0.7, and you want 1,000, 10,000, I think the years has to reduce. Okay, so it will take you just 5 years. It's actually 70, maybe you are part of the those that they instituted the company, by the way. But it's just a way to just show. So it's that with this program, we've designed something simple. And if you know HTML, you can create just a web kind of something to calculate it. I mean, maybe people will not use it, but it's kind of a project. It's your creativity. Okay. All right. And then it will take an input and everything. All right. That's just by doing. Though I've uploaded this particular module on the class page, so it doesn't have this code. However, I will send the update so that maybe if you like to also look at it, you can take a look at it. All right, I hope we are good. Okay, so I think there is another one. It's just the same thing. So kind of an increment. So count, comma. So count less than limit. So as long as the count, which is less than the limit, it's all going to print processing record count plus 1, and then count. So you update the count. So count equals to count plus 1. So for every loop, the count will be updated until the count gets to a value which makes the condition false. Then it will break. Then it is say done. Okay. All right. So when you have the code, maybe you can think around it and play with it. Yeah. I mean, create anything, and then I think I have to show you how to upload your code to your GitHub. So your GitHub, you can have numerous of these programs, and when you create it yourself, then you put it there. You put it in your repository so that you can show it to someone. At least you've learned Python, you've used it to create some small projects. Okay. This project, it counts. It counts. It's not the big data analysis, but some of this was what the person will know that, oh, actually, then you immerse yourself into the program, you understand what you did. Okay, but that one, I'm not sure that I will take you through, but I'll share with you a video on how to upload your items on GitHub. Okay. So if you have created some projects, I mean, a program, you can still upload it, and the process is very simple. Okay, so let's get with the break and continue, and then let's end for today. Okay, so the break and continue are some behaviors within the while loop, and they are exclusive for the while loop. That means that you cannot, I think so, you cannot use it in a for loop. Okay. All right, so the break statement says that you ask, for instance, you are scanning a data set for a critical data corruption. Okay, the moment you find one, you stop everything and raise alarm. There is no point processing the rest until the corruption is fixed. So there could be times that maybe you are running a program, you are scanning or checking maybe the individual items or the data within a particular column. Okay, so you are finding out, is there, let's say, a missing number? So the break, what it does is that once you are running the while loop and it finds a missing number and you provide the break keyword, the code stops. So it does not run again. However, the continue does the exact thing. So the continue, once the continue finds the object, it skips that particular line and continues. Okay. All right, so let's see that one in action. In data science, this is important because you'll be running some code like, let's say it's NA, okay? It's .NA, okay, or it's NA. I think the is.NA is for R. So it's NA is for Python to figure out whether there is an NA, a missing number in your data set. So Python actually uses some of this while loop below or underneath those particular functions that you'll be using. Okay, so what it does is that if you say it's NA, it checks whether there is an NA, there is missing values within your data set. And if there is, it tells you true or false. And you can even get the number of them. So Python uses a while loop to check this. So if it is an NA, it uses the continuous, so it skips all of them and count the number of skippings that it has made. And it returns to you that, oh, in your data sets, we have this and that values, okay? All right, so let's see that one in action. So we are scanning this particular data. Maybe we are not supposed to have a negative number. So when you see a negative number, stop running the code until that negative number is being converted to a positive number. So how do we do it? Okay, sorry. So we are using it in a for loop. I think it belongs to both the for loop and then the while loop. Initially, I said the while loop alone. Okay, so let's see that one in action. So a for loop for score, I mean the items over here in scores. If score is equals to negative 999, print, critical, corrupted value detected, stop pipeline, break, and then print process score, then you print the score, and then print scan complete. So we are scanning to see if this particular value, okay, is in our scores. Okay, all right. So it checks for the condition. So it picks this first one, it checks no. This 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 one, it checks it's true. If the condition is true, break, then it breaks your code. So it means that these ones will not be checked. Okay, so let's run it and see. So when you run it, okay, so processing the first score, this, second score, that, and that. When you go to the 99, because it meets the condition is true, because this 99 is actually equal to this. What happens is that this is going to print, okay, and then the processing will be terminated, then the scan will be complete. So that's what you have here. Okay, so maybe you are scanning to figure out whether we have this particular value in our scores. Okay, so this one, you can just write a simple program that checks for whether something is in something. Okay, which of the patient, if there is maybe kind of a validation kind of problem. Okay, when you have a problem that maybe you like to validate some items, and even if one item is wrong, the process should stop. You can use this break and this particular code. So depending on the problem that you want to solve, it will determine whether you have to use this particular code structure, the break. Okay, so let's note how the break was implemented. So it's kind of if something, we give a particular kind of output, and then if that condition is satisfied, then you break the process. All right, so here too we have another one. This is a smaller version of what, yeah. Okay, so the one that comes after the critical point, what we are trying to say is that once it meets, once it meets the first condition, which is error, all the rest of the program stops. So the loop does not continue again. So the program actually stops until you have the values correct. So if even one of the values, so provided the 99 was supposed to be here, okay, was placed here. Okay, you see that nothing will even run. And let's say 70. Let's run it and see. See, scanning scores, corrupted value detected. Because the first instance, the first value meets the condition. And so we have to break the loop. We don't have to scan through. Do you get it? Now. Okay, good. All right, so let's make progress on that. So we have another one over here. Okay. So we have many ways of doing it. So you can correct it from your code, or you can also write if score equals to this. Instead of breaking it, maybe you can correct it. That one you will not use the break. Okay. So if score equals to this, maybe change it to something. So here, for instance, maybe we want to do that. We can say that if score equals to this, let me just comment this so that it does not run. If score equals to this, um, maybe you can cause. Okay, so then we use the index of that particular value, which it is at index position 0, 1, 2, 3, 4, 5. Okay, so 5, then we assign it to a new value. Maybe we wanted to write 99. So in this case, this particular value will be updated with the 99, which is the right score that we have. Okay, that is in the case you want to change the value, if this value is considered. Okay, but in this case, that's not what we are trying to demonstrate. We are trying to say that when it meets a condition that is true, I mean, which must not be there, we have to stop the entire process. So we can see that in manufacturing, when, I mean, these are some of the code that they run in manufacturing. Okay, so the process is running, and they say that they have some conditions for the process. So maybe if the temperature of the maybe the fermenter or whatever machine is greater than this particular value, stop the process. Okay, so you see that the machine will stop when the temperature is too high, and then it will give you an indication, temperature too high. Okay, all right. So I mean that is how, I mean they build or that they build. Okay, so actually this 99 can be maybe a stone. You know that we have some machine that's, I mean, let's say for food factories, when they have, let's say, corn and other things, they have a machine that scans to see whether there is a metal. As the machine scans, it goes to this place, it finds a metal. That no, there is a metal in, so we have to stop the process and remove all the metals. Okay, so the break function will break the loop which is happening. Okay, until the metal is removed, then the process will continue. So once we remove this one, all the rest of the loop will continue. All right, so that's kind of an engineering kind of, but I mean it's also useful in data science, whereby you want to figure out some benchmarks, or you have some flags within your data that you want to fish them out. However, we are not going to implement the code like this because we've developed optimized functions that can perform some of this code for you. Okay, so we have another one over here, which is the same as, I think this one is different, right? The continual list comprehension. All right, so I think we have just some few models some few cells to run. Okay, so this is how the continue also works. So the continue jumps the error. So the breaking will stop at the error or at the condition, but the continue will jump it and continue. So here we have, what's the name? Some readings, okay? All right, so readings, let's say temperature readings or whatever. And then we say that valid total equals to 0, valid count equals to this. Therefore, reading in readings. If reading is none, if reading, so for each of the readings in this, each of the values here, if that value is none, I hope you remember this is none. So it means that if this value, and it means empty, it does not mean 0. So if reading is none, we don't know, it's empty. What are you supposed to do? Continue. Skip this entry and move to the next. And then valid total plus equals to reading. So valid total plus or equals to valid total plus 1. So what we are going to do is that here we are going to just add all these values, okay? But because the none is not a value, we cannot add it. So we want to say when you find these values, skip it and add. When you find it, skip it and add. That's the continue. That's what the continue is doing. So here we have the valid total equals to 0. So each time the valid total will be equal to valid total plus the reading, which is the individual values over here. This reading, individual values over here, because the none will be skipped. So it will be updating itself until the last value. And then the valid count will be counting the number of values, but not the none that are present. All right, so that is what this code does. Let's run it and see it in real action. So the number of valid readings has say so 1, 2, 3, 4, 5, 6, and then the total will be the sum of all these. Okay. All right. So I mean that is that. That is how it works, and I mean the average too. Average, we all know the average. So valid total, that is the total over the valid count, which is the number. Okay, we cannot use the len over here because when you use the len will count these ones also. However, we don't want them as part. That's why we set the valid total to 0. Okay, in order to increment it based on the values within the readings, which are real values, but not now. So in Python, you can, or when you're doing data analysis, you can run a function like the mean. Okay, so when you run a mean on your data set, the mean actually involves the addition of values within a particular column of your data set and then dividing it by the length. When you have a missing value, you cannot add 95 to that missing value. So what the mean function does is that it removes all these things, and this is basically the code behind the mean function. Okay, that's basically the code behind the mean function. All right, so I think we are done. Okay, let me end with the list comprehension and then let me open up for questions. Okay, so when we talk of list comprehension, you know that earlier, if you want to create a list, we need to write the values and everything. Okay, but we have something that we call the list comprehension, which is also part of, I mean, this is the prerequisites of the advanced list and then advanced data structures. Okay, so what we are saying is that the syntax is expression for item in collection. So the list comprehension is a combination of a for loop and then in a list, okay, in a particular kind of, let's say syntax, okay. And then you can also do it with a condition or with a transformation. Let's see it in real action so that we can appreciate it. So scores equals to these values, okay. So loop version. So if we are writing a for loop in order to update values over here, so we are adding each of the values here plus 5. So a teacher gave a test and then maybe he wants to add 5 to each of them, their scores. So we say that curve loop equals to, or curve loop, or maybe updated, or maybe scores or anything, equals to an empty list. Instead that for score in scores, so for each of the items over here, curve loop dot append what? The score plus 5. So this one plus 5, then append. This one plus 5, then append. This one plus 5, then append. This one plus 5, then append, until the loop is complete. So this same code, we can implement it this way. And how do we do it? We say that curve loop equals to score plus 5, which is your score over here, the scores over here, for score in scores.
Daniel.
Yes.
Please pardon me, but I don't understand what you are saying.
Okay. All right. So let me come again. Okay. So what I'm trying to say is that, let me just comment on this. Basically, when we want to append a number of values to a list, this is what we do, right? So we say that we have these value scores over here, and to each of the scores, we want to add 5 to it. So basically, if you want to do this, what we can do is to write a for loop. Okay, so the for loop will be for score in scores, which is the for each of the items in this particular list. Curve loop, which is this empty list. We know that the list has an append method, which actually adds our values to the list. So this curve loop, let me just use updated scores, because the curve loop is kind of confusing. Updated underscore scores, so that we can relate. Updated scores, I have to change it here. Updated underscore scores. Okay, updated scores. Good. So we have set a variable, an updated score, to an empty list. because we don't have those updated scores, okay? And we don't want to add it manually. We want the program to do it for us. So instead of for score in scores, for the values, each of the items or values in the scores, updated scores, which is this empty score, so dot append. So append what value? Score plus 5. So in other words, maybe we can say that new underscore score will be equals to score plus 5. And then maybe use that new score here. Okay, score. Okay, so basically this new score over here is the same thing over here. Okay, but instead of creating another variable, we are just passing this one as a parameter directly here. But by the way, I'm going to leave it like that. So this is basically how we are going to update. So let me just comment everything there and print the updated score. So print updated scores. Okay, so you see that you have all the scores over here with your 5 added. So 78 now becomes 83, 65 becomes 70. Okay, so basically this is how we update a list, okay, based on what we know. But we are saying that instead of writing all this long code, we have a shortcut, and this is the shortcut. So let me just bring this one here. So instead of writing this, we can say that updated underscore scores, okay, is equals to, which is this one, okay. Then you create your list. But instead of writing this for loop outside, we write it inside. So what do we say? We say that the score plus 5, that is the value that we want. For, which is the for loop, for score in scores. Please, do you get it? All right, so what we are doing is that we have, so imagine this code is not there, okay? So this is what we have. And we are putting this particular code into the list, okay? So that we don't have to use the append again. And that's how we do. So we say that the score plus 5, which is what we want to calculate for score in scores. So it's kind of for score in scores represents this particular code. So for score in scores, calculate score plus 5 and add it to the list. Okay. So this is a short form of actually writing this particular code, and that's what we call the list comprehension. Likewise, when I comment all this code and then I run the new code, which is print updated. So let me say comprehension in order to differentiate it. So updated comprehension. What do you think will happen? So what will happen is that you see that we are having the same result, the same outcome. Okay, so it's a shortcut of writing for loop when you want to output the value into a list. This I hope we are getting it. Grace, do you get it? I hope you are the one who you are the one who asked the question.
Yeah, it's fine. Thank you.
Okay, you're welcome. So basically, that's what it does. So we call it list comprehension. You can do it for a dictionary too, and all that. Okay, all right. So I'm just trying to undo them so that we have what we have. Okay, good. Okay, I think that's one you are running to. So you're going to see, and then the comprehension version. Okay. All right, so we have something like that over here. The same thing. So instead of writing a for loop, okay, so we are extracting only the pass marks. I mean, those that they got marks of 70 and above. So we are saying that score for score in scores. So this is a for loop. So for score in scores, so for each of the items in this, print that item if the item, which is the score, is greater than or equal to 70. Very simple. So you are going to get all the items that are greater than or equal to 70. And that's what we call the list comprehension. It simplifies your code without allowing you to write a for loop, because this is how we are going to write for score in scores, then we are going to bring a colon. If score greater than 70, print score. That's what we are going to do. But instead of doing that, we can just do this and put it to a list, and then, I mean, brings the output, provided we want to um, collect the output of the of the of the of the of the program in a list. And it can be done for dictionaries too. But for now, let's take the list now. I think there's another one that does the same thing. So here it says that fever, if so here it says that fever, if temperature greater than 37.5, else normal for temp in temperatures. So what are you saying is that if you are going to write this in a normal for loop, against that for temp in temperatures, then you bring your colon. If temperature is greater than this, print fever, else print normal. And that's the same thing that we are doing. So we are saying that fever, so print fever, if temperature is greater than 35, else print normal or output normal. If temperature is not greater than or equal to 37.5 for the temperature, temp, or for the values within the temperatures. So once you do that, you are going to get a list. So it's going to tell you whether which of them is normal or is not. Okay, so I mean, it's a bit. I think you are new to it. So, however, nothing is new when you actually take your time to go through. So I'll suggest that you go through. All right. So I have a comprehensive, um, long exercise here. So please, this one you are returning it, but let me just come back and then talk about that one. Please, the way we are not submitting our assignments at all. Okay, I mean it also helps. It challenges you. Okay, yeah. So maybe you can just give it a try. If you find that is how you know that you can actually do the thing, because it's one thing to think that you know, and there is another thing for you to actually do it, to have the evidence that no, this thing I can do it. Okay, sometimes we never try. We have the head knowledge, but we never try. But once you try, you realize that no, it's not as easy as I was thinking. And it also helps you to stimulate that kind of creativity, and okay, it makes you think a bit. Because like if you are not solving any problem, if you don't think, you don't find solutions, you don't think about what you are doing, okay, to find solution. However, if you want it to be something that you want it to contribute much to your life, you have to also tackle problems. And these problems are not difficult. Okay, you can find information anywhere. I mean, it's not this one. So when you're reading something and you just ask questions, you use Google to figure out. It also helps you to know how to solve problems. And all these, if you are able to do it, it can be part of the things that you can upload on your how do we call it? Um, what's the name? On your GitHub. Okay, it's an evidence that you've learned the Python, because you have notebooks, you have problems that you solve it by your hand, and you know that anything that you do it by yourself, you are able to explain it more than anyone else. Okay. All right. So, I would like to leave you with this message that I heard somewhere. So they said that it is not about what you know, about what can you do with what you know. So it's not about saying that I know Python, but what can you do with the Python that you know? And that is what matters. So in as much, I mean, both of them matters, but one has a lot of weight. So if you know, come and show us what you can do with it, so that we will believe that indeed you know. Okay, so please, the assignments have been there for you. So this one, I will create the space for it, and you are supposed to submit it on Monday. Okay. All right. So please, we are done. Any question? If you have any question for me, I'm ready. Okay, so I think there is no question. So if there is none, then I think we need to call it a day. All right, so thanks for having you, and then I hope it's been a fruitful session. So please do well to take your time and make time and go through it. Okay, it's a real skill. Okay, in this age now we are moving to the age of computers. So at least you should have some technical knowledge about all this programming language. It adds up to your entire kind of portfolio. Okay, but you can't say that I know, but I can't do anything with it. So since you are here, why don't you do it now and then get over it? All right. So I'll see you. I will see you. So we will discuss that the next time that we meet on the page, so that I mean it will be a time that will favor most of us, if not all of us. Okay, because from next week going, we'll be meeting at intervals of 2 days per week, so that we can have time to also work on the assignment. Because the assignment it will come, and also we will be receiving some quiz. So on our next meeting, we will have a short quiz like the one that we did. And for those that they weren't able to do, please, the quiz is still on the class page. Visit the class page and then locate the quiz and then try your hands on them. Okay. All right. So I will see you then. Enjoy the rest of the evening and have a wonderful holiday weekend. Okay. All right. So I think yeah, I think we've all heard. So please kindly do justice so that we can make progress. Okay. I mean, it's a good thing to do and a good skill to have. And the roadmap that I'm taking, if provided you are following from the beginning, you see that you have a good skill and a lot of understanding of all these things. We are not doing it randomly. We are doing it systematic so that you appreciate. All right. So with that said, I think we have to call it a day. All right. So I'll see you then. It's until then. Stay safe. Bye.